Today we'll be discussing on data entry. Last week, we have seen the overview of SPSS, and we have seen how to do some basic analysis. So today we'll move forward to see how to create data or how to do data entry on SPSS, and also how to interpret some of this analysis that can be done on SPSS. So at the end of this section, you should be able to describe the process of data entry on SPSS. You should be able to create variables on SPSS. You should be able to enter values in SPSS data view window. You should be able to enter values for categorical variables. You should be able to perform descriptive statistics. You should be able to interpret analysis outputs. You should be able to create graphical representation of descriptive statistical analysis. You should be able to calculate and interpret Z-score. You should be able to define, calculate, and interpret Pearson correlation. And lastly, you should be able to create scatter plots on SPSS. Now, please, as you're joining the class, kindly mute yourself so that we'll not be interrupting. You'll not be interrupting the class, please. But if you have any question, you can always raise your hand, okay, or draw my attention. Now, before you can run any analysis, before you can perform any form of analysis, you must have a set of, you must have some data sets, okay? And if you have the data sets, you need to input them into your SPSS software before you can perform any sort of analysis on those data sets. Okay? Now, what do we now mean by this data entry? Of course, I believe you're all seeing how the interface looks like, how the SPSS interface looks like from our previous class. So it looks like Excel sheet kind of thing, but the difference here, one of the major differences is that it comes with two buttons somewhere here that will allow you to switch between data view as well as variable view. Data view window is where you input your values to your variables, while the variable window or variable view window is where you define your research variables. Okay, we have gone through the process of doing that last week, and again we are going to see more about that in today's class. Now, when we talk about data entry in SPSS, data entry in SPSS is the most important task involved in any form of analysis. Like I said earlier, without your data, you cannot perform any analysis. And as long as you have data, you can perform any form of analysis. The most difficult part of it is how to interpret the analysis results. That's the only difficult part when it comes to SPSS, because SPSS makes those analysis look very, very simple. Okay. Now, data may exist in any form. We have discussed about data type, data format, as I think last week or 2 weeks ago. So it may be written on a piece of paper, or it may be typed in a computer in raw data form. Before doing data entry in SPSS, the first thing is you need to launch your SPSS software. That you need to start the SPSS application. So you're going to have an interface that looks like the one we're having towards the right of the screen. As soon as SPSS opens, a window will appear, which is called the data view window. Okay, from this button, you can see the data view button is currently selected, which is showing your data view window. Okay, if the data size is small, then the data entry in SPSS can be done manually if it's small. However, when the data size is large, then the data entry in SPSS is not possible manually. In such case, the data can be imported into SPSS, whether they are in MS Excel or CSV or SAS or Stata, etc. I showed you how you can input data through MS Excel in our last class, and the various conditions that must be fulfilled before you can input data from your MS Excel into your SPSS software. But in any case, If your data is kind of small, then probably you can do that manually. Then also your mode of data collection also depends. If your mode of data collection is kind of a manual, I mean, it's kind of one-to-one data collection, something like that. Later you administer your questionnaire to someone, to limited number of people, then probably you can enter your data manually. But those kind of data that you collect through software, probably through something like SurveyMonkey or any type of questionnaire software that allow you to reach out to higher number of people, in such case, it may be difficult for you to enter those data into your analysis software manually. So as a result, you may need to find a way to input them through any of these platforms, maybe MS Excel or CSV or SAS Data or even database. Okay, so but in any case, in this particular section, we're going to see how this can be done. For assume that we are using this small size data, of which if you have a larger size data, you can just pull your data into an Excel file and try to format them, clean the data up, and make sure that they fulfill those requirements that we mentioned in our last class. Once that is done, then you can follow the procedure we mentioned last time in order to get them uploaded on your SPSS application. Now, how do we now create variables in SPSS? This one we have discussed it last time, but again, let's quickly look at it in detail. The first thing is you launch your SPSS application. As you open how do you do that? You double click on the SPSS icon on your system, and that will open up this particular interface. Now, a few things to know about naming a variable in SPSS. I've mentioned this to you last week, but I did not go in detail. One of the conditions that you have to make sure that you maintain is that no spaces in your variable name. Spaces are not allowed in a variable name. For example, if you have two words that you want to join together to make a variable name, like first name, last name, city name, or maybe phone number, you cannot put space in between the two words because blank spaces are not allowed in variable name. So if you want to join two names together or two words together to form a variable name, you can use underscore, something like this. Okay, you can use underscore. Variable name, another condition you have to make sure you put into consideration is that variable name cannot begin with a special character. Special character involve file, hearts, and ampersand symbol, and so on. So you cannot say something like heart first name, or file first name, or ampersand first name, or equality first name. No, all those kind of things are not allowed in the formation of your variable names. And also, variable names cannot begin with a number, with a digit. So meaning that you cannot start with one first name, or one name, or two name, or three name, or four name, and so on. Okay? Digit cannot start a variable name, cannot be the first character of a variable name. Each variable name must be unique, meaning that variable names cannot be duplicated. Okay? You cannot have first name in one as a variable name, then you go to another variable and you give the same variable name as first name. No, that is not allowed. Each of the variable names must be unique. Variable name should not be more than 64 characters long. Okay, it should not be more than 64 characters long. Otherwise, it will be difficult to, even the result of your analysis will be kind of filled up, and again, it may not be readable to some extent. So it's always advisable to make sure that it is below this number of character. Okay, so these are the conditions that you need to make sure that you put into consideration while creating your variables on SPSS. Of course, the first step is to launch your application, which we have done. Now, next is to create these variables. How do we now create the variables? You switch to your variable view. look at this place, you have data view, I have variable view. So all you need to do is to click on this variable view button. Once you click on this button, this will bring you to this place. This is the variable view window where you determine, I mean, you enter value for each and every value, each and every component of this variable, each and every attribute of this variable. So for example, here we have about 4 variables. The first one is ID. We set the type to numeric. I've explained what each and every one of these actually means in our last class. So, but for those who are joining us for the first time, please check our previous slide. I will be sending the slide to you at the end of the class. Okay, so please be patient. Now, as per the type, this type specifies the kind of value that will be stored inside this particular variable. So if this variable will take text value, then you set this to string. If this variable is going to take date, you set this type to date. If it's going to take a number, then you set this to numeric, and so on. There are other types that you can explore inside this place. And how do you do that? All you need to do after you have typed your variable name, you come here. By default, numeric will be assigned. So if you now want to change it, just click on this place one time, and you're going to see about 3 dots that will appear somewhere here. So once you click on those 3 dots, then the page where you are going to choose, the page that will allow you to choose or select your data type will be displayed. Then you can select whichever data type you want and click on OK. Then the data type will be selected. Okay, but by default, once you type a variable name, all these values will appear. And for decimal, you're going to have 2, just like how the last 2 variables looks like. This will also come like that, so you don't have to worry. If you need to increase, you increase. You don't need, just leave it where it is. Now, for the purpose of this ID, and we put type as numeric because we are going to input digits, numbers. We are going to input number into this place. So we use numeric. The way to keep it as A, decimal 0 because it's a whole number. We are not keeping any form of decimal places value. Then here we have label. Label tells you, give the description about the variable. Okay, so it's good for you to have a label because it will make you understand why you created this variable. Even if you revisit the data after maybe after a month or 2 months, or 3, or even a year or 2, you understand why a particular variable is created. Then values. Values is, for example, if you have categorical variable like gender, this is where you define the values for that particular variable. Okay. I think I'll show you how this is done, but I'm going to show you again how it is done today. Then missing values. Sometimes some of your respondents may decide not to supply answer for some questions, and they will decide to answer some. So for those questions they have decided not to answer, definitely you'll be having missing values for those responses. And in SPSS, missing values are dropped during analysis. Okay, then also there's how if your missing value is numeric like this, SPSS will automatically replace that space or that missing value with a period. Okay, but if the missing value, if the variable type is kind of it's a text or any form of other type, you may need to define how you want SPSS to handle such situation, maybe by representing a certain character or certain number or certain figure. Okay, so with doing that, you just need to click on this place, then click on the ellipse, the 3 dots that will appear here. You're going to see 3 options there. You can choose whichever one that suits your case. But in any case, as long as the variable here is numeric, SPSS will handle missing value as a dot, and those missing value will be dropped during your analysis. And I'm going to tell you, they're going to say that, okay, this is a missing value. Okay, I'm going to show you one about this in a short while during one of the examples I have. So But for columns, these columns also come by default, so you don't have to worry about it. The only thing is that when you switch to the data view, you're going to see if this space provided for your variable name is not enough, you can straight away extend, just like what we do in Excel. If you cannot do that, just come back to this variable view window, then come here and increase this column size. Once you increase this number, how do you increase? Just click on it, and you're going to see up and down arrows here. The up one is to increase, right? The down one is to decrease the value. So depending on what you want, you can see to what by default you'll be getting hits. Okay, then align how you want your data to be, whether you want it to be right side alignment or left side or even center justified. Then here you choose your measure for each of the variable. Okay, and when you are choosing this, your measure can be either nominal, ordinal, or scale. Okay, then for row, you have other options here that you can also actually select from. We have input, we have target, and many others, which we have discussed last time. Please check your slide in order for you to know which one to choose. So in this case, we have about 4 variables with their corresponding attributes. Okay, so once this is done, the next thing to do, we said the height and weight are both quantitative variables, and that's why we assign scale to them. And of course, we make them to 2 decimal places because we presume that they may be behind to something point something. So that's why we make them 2 decimal places. If you want to make it 3 decimal or 4 decimal places, you just have to increase this value. Then both are set to scale because they are both ratio level variables. Okay, so in any case, these are the sample variables that we'll be working on, and this is how to create these variables. Now, after you have created your variables, the next thing to do is to enter data into those variables you have created. And how do we do that? You need to switch to your data view window. Okay, remember, before we went to the previous slide, we click on variable view window. We click on the variable view button. So same button will still be showing at the same spot. So in order for you to go to this place, just go down to that same spot and click on the data view button, and that will bring you to this place. So these are the data that we entered. These are the variables we created just now, and we enter this data into this particular variable. So, like I said last time, these are cases. Okay, these are cases. These are cases. These are cases. So one respondent is the first case. The ID of the first case is 1. The gender is 1. The weight is 68.00, and the height is 150.00 centimeter. So now these are the weight and height. The weight is in kilogram, where the height is in centimeter, from what we have defined here. Okay, from what we have defined here. So now, another thing you need to put in the consideration here is that here we have some missing values. For our case 11 and 12, we have missing value for weight and height for those participants. So probably those people have decided not to enter their weight and height during our sampling or during our data collection. Probably they don't know, or probably they just decide not to reveal their weight and height. So as a result, while entering those data into your SPSS, then they will become a missing. They will become missing values. Okay, and that is why I can say it's ... because the type of these variables is numeric. Okay, so we have this ... In any case, we have all these values into where the gender, we have 1 to represent male, we have 2 to represent female. So wherever you see 1, we have male. Wherever you see 2, we have female. So meaning that the first case is a male, the second case is a female, the third case is a female, the fourth case is a male, fifth case is a male, and so on. Okay, the ID is just a ID, just the ID of the participant or the respondent. Okay, so we have this data in here like this. So the next thing is that we need to enter values for the categorical variables, even though this is supposed to have been done earlier, but I just have to come back and show you how. So to do that, you go back to your variable view window, and you click on this place, which is under value for gender. So once you click on this place, this box will open. So here, what you need to do is to enter the value you want for your female, and you enter the label for that particular value. Once you do that, the next thing you do is to click on this add button. So the first thing I did was to enter 1 here, and for the label, I entered male, and I click on add. Immediately I click on add, I got this. 1 is equal to male, meaning that I'm using 1 to represent male. Okay, then for the second one, I'm considering just male and female in this research. So for the second one, I just entered 2 for the value, and I enter female for the label. So next thing is to click on add. Once you click on this add button, this is what you get. So 1 represents male and 2 represents female. If I have more, let's assume you are looking at level of studies. Okay, so you want to use 1 to represent maybe high school or primary, 2 to represent high school, 3 to represent tertiary institution, and the likes. Or probably you want to use 0 to represent undergraduate, maybe first degree, 1 to represent masters, and 2 to represent PhD, and the likes. So you can always do that in this same fashion. Okay, so once you're done, what you need to do is to click on OK. So once you click on OK, then the data will appear here in the curly bracket. Open and close curly bracket. It will appear in open and close curly bracket. So in this case, this is how we got this male and female. So we use 1 to represent male, and we use 2 to represent male. And whenever you have a categorical variable like this one that has only 2 variables, only 2 values, okay, we call it dichotomous. And of course, there are some certain tests that can be applied to this kind of categorical variable. And so some tests that also can also be applied to variables, to categorical variables that has more than 2 levels or 2 values. Okay, all this will be demystified as we move on. Okay, but for now, in this example, we're using just these 2, and this is how this male and female were created. Okay. Now, after you have done that, the next thing is to analyze this data. Let's perform some kind of analysis. And one of the simplest things that we can do is to count how often things occur in this particular data set. For example, we can check how many males and females participated in the survey. So we want to see their frequency. Okay, and to do that, all you need to do is to click on this Analyze tab. There's a tab here called Analyze from your SPSS data editor window. So once you click on this Analyze, how this list will drop down for you. All this list shows all sorts of analysis that can be performed on SPSS. That shows you how powerful SPSS is. So, but in this case, you only perform statistical analysis that goes in line with what you want, not that you just do everything. You cannot do all, okay, because some of them are tailored to a particular analysis. So now you click on Analyze, then the next thing is select Descriptive. Under Descriptive, we have other options such as frequencies, descriptive, explore, crosstabs, curve analysis, ratio, PP plot, and QQ plot. Okay, so in this case, we want to just see the frequency. Remember, we only want to know how many males and females participated in the survey. So as a result, we only want to see the frequencies. So you click on frequency. So when you click on frequency, that will bring you to this particular box. So here you can see frequencies at the top of this, at the title of this window. So towards the left, you will see all your variables. And towards the right, you see another box for variables. And of course, you have some options that you can also make use of towards the right. So all the variables in your data set are on the left, and the variables that we want to analyze go on the right. So you can select a variable for analysis by clicking on its name, and then click on this arrow between the boxes, which is this one. Alternatively, you can just drag and drop the variable into this place, or you can even just double click on the variable name and surely appear here. Okay, so in this case, we now want to add these 4 variables into this place. So it's either you select all at once and you click on this to move them in here, or you can double click them and they will appear, or you can just drag and drop them into this place. Either way, you can always get something like this. Okay, so once you are done, so the next thing to do, you just click on OK. Okay, just click on OK. So once you click on OK, this is what you'll be seeing. Okay, this is what you'll be seeing. Now, this is your output window. This is your statistic output. This is your SPSS output window. Now, when we compare with other statistical analysis tools, SPSS will give you a huge amount of output. I mean, it will even give you more than what you need. So, but the major issue here is how do you interpret this output? So the first thing you see here is a summary of the variable, okay, which is labeled as statistics. So here you can see we have n, which is the number of entries, and here we have valid and missing. Okay, meaning that here now we have 12 valid scores for gender, okay, with no missing value. You can see missing value is 0. Okay, but for height, we have 10 valid values or scores, okay, which is just 10 and 2 missing values. So valid is equal to participants for whom we have scored. Okay, participants for whom we have recorded the cases. Okay, so these are the valid participants for each of these variables. So the first frequency table is for gender, which is this. Okay, and the total tells us that we have 12 valid scores. Okay, here we have 5 for males and 7 for females. The 5, notice that the column for percent and valid percent, which is here and here, they are exactly the same because we have no missing value for gender. If we had gotten some missing value for gender, then this course will not be the same. Okay, so the second frequency table is for weight, which is this one. Okay, now remember that we have missing values for 2 weights, for weight for 2 of our participants. So we see the value total is 10. If you scroll down a bit, you're going to see the value as 10. The total should be 10. But because of the screen, I could not screenshot all. But when you run the sample on your own, you can testify. You see what I mean by the total value is 10. 2 values are missing in the data cell called missing value, just like what we have here. and the total is also 12. So we see that the percent column is different than the valid percent. Okay, 12 now you will see what we mean by this. And the percent column is calculated based on the total sample size of 12. Okay, while the valid percent is calculated on the valid n of 10 participants for whom we actually have data. So those that we don't have data will not be counted. So towards the end, you may now have the complete value. You can see from here, valid percentage is 10 because it's 1, and the cumulative is 10. The next one is also 1, so the valid percent is 10, and the cumulative will be 20, which is 10 plus this 10 will give you 20, and so on. So when you get to the place where you have the missing value, those missing value will be deducted. So as a result, you cannot have 100%. Okay, that's why the cumulative percentage will reduce. So anyway, that is the little descriptive analysis that you can get from here. You can see that for the frequency, we have 5 male and 7 female. And of course, these are their percentage and their valid percent as well as their cumulative percent, both for gender, weight, and height is also down there. So it just looks like something like this. Now, I said this, we can make some graphical representation of our analysis instead of having the frequency and just showing all sorts of figures in a table. To do this, we need to click on Analyze again. Then go to Descriptive Statistics and click on Frequency. This will bring you to the same page that we have, the same window we had earlier. This time around, instead of clicking on OK, you need to go and select some graphical representation tools that you need. And how do you do that? You click on Charts. You can see Chart button here. So when you click on this chart, this will open up this particular window you're seeing here. So what you need to do, select bar chart. If you want pie chart, you can select pie chart. For histogram, you can select histogram. But one of the things you need to understand here is that you have to ensure that you are selecting the correct tool for the right data or variable. You are going to see this in a short while. So now, in this case, we are choosing bar chart. Okay, and here we have chosen percentage. Okay. So we uncheck display frequency. So here you click continue. Okay, once you click continue, to bring you back to this place. So display frequency tables we don't need because we already have the frequency table from our previous analysis. But if you want to repeat it, it's also fine. Yes, you will only be duplicating the same result you had earlier. But we don't need that. That's why you just uncheck this. So once you uncheck this, just click OK. But if you're running this for the first time, then you don't have to uncheck, okay? Especially if you want to see the frequency tables. So you click OK. So once you click OK, this is what you get. So in the output window, you can see that the chart for gender is kind of nice, and it shows us the percentage of the male and the percentage of female who have participated in our study. And also, we also have the statistic table, which is from a description from a descriptive statistic that shows that the valid cases for gender is 12 rather, without any missing value, and the valid cases for weight and height are 10 respectively, with 2 missing values respectively. Then you have something like that. So at least you have some kind of graphical representative. Now, here we have 2 distinct bars, one for male, one for female, and we can estimate the percentages of each. Now, we then look at the bar chart for height. The options don't look good. If we scroll down, you see something like this. Okay? We can do better by running a different analysis for this particular one, meaning that you can represent this in using a different tool. So to do that, you follow the same route, analyze the statistic frequency chart. This time around, you choose histogram instead of bar chart. when you choose histogram, then you check show normal curve on histogram. Check this particular checkbox and click on continue. So once you click continue, that will bring you back to this particular place. So the next thing to do, you click on statistics button here. So here, that will open up this place. So this place, you can choose what you want to choose, whether your central tendency, whether you want to check for mean, sum, median, mode, depending on what you want. Then, of course, if you want to check for standard deviation, variance, minimum, maximum, standard of error mean, and the likes. Then, kurtosis, skewness, if you want to check any of this, all you need to do is just to check the box that you want. But as this example is concerned, we just choose what has been selected. So we just click on continue. So once you click on continue, that will bring you back to this window. So all you need to do is just click on OK. And when you click on OK, this is what you get. Now, your output window should display what you have here. Then you notice that all the statistics we asked for were displayed on the statistics table. So here we don't just have the number of valid cases and missing cases. This time around, we now have the mean, we have standard error of mean, we have standard deviation, we have the variance, we have the minimum and maximum, and the sum. Okay. So if you scroll down a bit, you're going to see the histogram for this particular frequency. Okay, so the important thing to learn here is that you should choose the statistics and the graph that are appropriate to your data. When you are looking at nominal variable like gender, that should be reported with frequencies and the bar chart. But when you are talking about scale variables like height or weight, this should be reported with mean, standard deviation, and the histogram. So know when to use these tools. Now, if you want to examine the differences in height based on gender, okay, we want to examine difference in height based on gender, we can straight away go to analyze again. Then instead of going to descriptive, we can go to compare means. It's another form of analysis that can be performed on SPSS. So when you click on compare means, then from this compare means option, you click on means. So once you click on means, you're going to have something like this. Don't forget, we want to examine the differences in heights. We want to know who is taller between males and female. So that's why I want to check the differences in height based on gender. So because of that, we're going to put the height as a dependent list. So all you need to do is to drag and drop the height variable into the dependent list. Then you drag your gender into the independent list. Okay, once that is done, you click on OK. Once you click on OK, this is what you get. Now you can see the mean and the standard deviation for males and females separately and together. So here we have the case processing summary. So here we have height in centimeter by gender. So then we have the total number of cases, that's the total number of valid cases. Okay, it's 10. And this amount to 83.3%. And we have cases excluded, which are the missing value, okay, which are just 2. And that amount to 16.7% of the total cases, of total respondents. So then total, we have 12, and the percentage is 100%. Now, if you look at this report, we have the gender, which is male and female. And these are their means. Okay, these are their means. For the mean, for male, it's 151.000. And for female, it's 145.400. So the number is 55. We have 5 males and 5 females. And we have total to be 10. Remember, we have 2 missing values. So the standard deviation for the male is also shown, and the standard deviation for the male is also displayed here. Okay, now there are each, okay, that's what I just mentioned here. There are 5 each for males and female, total is 10. And we'll see that males were a few centimeters taller on the average than females from this value. Okay, males are higher than female, a few little points higher. So that's telling you that males are kind of taller than female from this result. Then the total mean and standard deviation here are the same as the value that we got earlier using the frequency command. So overall frequency count, charts, and descriptive statistics are a great way to take a peek at your data and see just what you have. And it is a good idea to do this before running any kind of analysis because they describe what your data set looks like. Okay, so now after you have done this, you may even want to get more. Okay, you may want to get more descriptive statistics. And how do you do that? You go to you click on analyze again. I go to descriptive statistics. I click on descriptive. So here you move the following variables into this place. Now here you can click on options. Remember the first one was to go to frequency, right? This time around I go to descriptive. So you will click on options. So from these options, we have all these options that can be selected. Okay, here we are presented with all kinds of options for descriptive statistics. We have mean, we have sum, we have standard deviation, standard dispersion, we have variance, we have range, and the likes. So some of these options are already checked by default. Others are available to check if we want them, that is, if they are necessary or if you are interested in them. So, but in this case, just go with the default selected options and just click on continue, then we click OK. And with that, you get more results like this. So in this case, we have some useful information on this output window. We see the number of values called for each variable. Okay, number of values called for each variable. We also see the valid n, excuse me, list-wise, which is the number of complete cases with no missing value. Okay, remember I told you the missing value will not be included in the analysis. That is how SPSS is designed. So for gender, we see that the minimum is 1, okay, and the maximum is 2. Don't forget, we use 1 to represent male, and we use 2 to represent female. So he's looking at this based on the value we have entered in here. So that is useful at least for checking that we do not have any data errors. But the mean and standard deviation for gender is pointless. So if you had entered the wrong value for your gender, let's say you mistakenly enter 0, or you mistakenly enter 1, or you mistakenly enter something outside 1 or 2, you're going to see it here. So if you had entered like 4 or 5, something like that, then your maximum value here will be 4. Okay? So, but as it is now, it shows that these are the values we have defined, and it's showing that we have not entered the wrong data or value for our gender. Now, the average of 1.58 for male and female, it doesn't really tell us anything, but it's still there. Okay. However, the mean and standard deviation for height and weight can be useful. Okay. So, and we're going to see how that can be useful. For example, the average weight was 58. Okay, 58.50 kg. The standard deviation was 9.49. Okay, that is if you approximate it to 2 decimal places, which tells us that about 2/3 of our participants are going to weigh between 9.49 kg heavier and 9.49 kg lighter than the mean of 58.50 kg. That is the interpretation of this particular descriptive statistics. Now, if you, another method to get descriptive statistics that will give you even more details about each variable and more options for plotting and statistics given below is using Explore. So how do you perform this Explore? You just go to Analyze, then you click on Descriptive Statistics. Okay, then here you see we have Explore, another statistic analysis called Explore. So when you click on this Explore, this is what you get. You come to this window. So you need to move the height and weight to the dependent list. Okay, then you click on Statistics, this button. Then you look at descriptive, outliers, percentiles. What outlier means that outliers are data points that are far from other data points and they can distort statistical results if care is not taken. I mean, once they are there, they can distort your statistical result. What are outliers? For example, you have 1 and 2 for male and female. And suddenly while inputting your data, let's say you are talking about 1,000 participants, and instead of you to enter 1 and 2, 1 and 2, 1 and 2 for the response for the cases, you suddenly mistakenly enter like 10, 15, 20 in some cases. Those will have some kind of issues with your analysis. Those are examples of outliers. So outliers are data points that are far from other data points and they can distort statistical results. So you have to be cautious on them. Then again, how do you know? How do you identify this? I'm going to show you this in a block diagram in a short while. But anyway, so you check this if you want to check whether there are some outliers in your variable or not, in your data set for these variables or not. So you check these outliers. Then you check this percentile as well. Then you click continue. So once you do that, then you click on plots. Once you click on continue, to come back to this place. So next is to click on plots. So when you click on plots, you choose histogram. By default, you're going to this term and leave. Then you can have histogram. Then also your box plot, we have factor level together, dependent together, non, depending on what you want. You can select whichever one that's suitable. But we are more concerned about the histogram here. So you click continue and you click OK. So once you do that, this is what you get. So here we have every kind of descriptive analysis you could ever dream of. For the weight, we have, of course, we have the case processing summary at the first here, which also actually shows us what we had, similar to what we had earlier in their first frequency table. So here, for weight, you have 85% confidence interval. For me, we have lower band, upper band, we have trimming, medium, variance, standard, maximum range, and the likes. We have this for all the variables. So now we have a special box for percentiles. And also we have another box that will identify if we have any outliers or extreme values. The output window also came with histogram plus a small stem leaf plot and a new graph called a box plot. You can see that we got a lot of information here. So this box plot looks like, I think something like this. Oh, sorry, it's not here yet. I'm going to show you soon. But anyway, here we have all sorts of statistics that has to really do with the variable. Each of these actually have a meaning, but depends on what you are looking for. And I'm not saying that you must actually run all the statistics in your research. You only run the one that goes in line with what you want based on your requirement. If you need it, you run. If you don't, then just stick with whatever you needed. Now, we can even split all of this by gender. And how do we do that? You go to Analyze, Descriptive Statistics, and click on Explore. Now, when you come to this place, initially, this was what we had earlier. We had nothing inside the factor list. So this time around, you now drag and drop your gender variable into the factor list. So because you do that, once you do that, you can now click on OK. Once you click on OK, you realize that your cases will be segregated to both values for your gender, which are male and female. So for weight in kilogram, you have for male and for female. And next is for height, also for male and for female. So instead of having this together, it has been separated by gender. So, and the same goes to the descriptive you have in here. So the weight in kg, all this will be computed for male, and same goes to female, and so on. The same thing will be done for height as well. So now, this is how a box plot looks. So if you have any form of outliers, you're going to have a dot somewhere here or dot somewhere. If the outlier goes more than the value of others, you're going to have some dots somewhere here. But if it's extremely below other values, it will come somewhere here, dots or there. Okay, it will form like a dot somewhere here. Now, a box plot are now side by side so that we can do some comparison to what we just did just now, the analysis just now. So this is an example of a box plot, and knowing about these options for descriptive statistics can help us to visualize our data depending upon the level of information that we need. And before I go there, let's quickly look at some of these components of these box plots. You can see we have something like this that there's a line here and there's another line here. There's a line here, there's another line here. Okay, this line that comes beneath here, both lines are referred to as the lowest observation. Okay, lowest observation in weight. This is for weight. So we can say these are the lowest weight observation for male and female. And if you look at this, if you check what we have inside, okay, let's look at this female, for example. For the female, if you go back and check what we have from our table, you will see that the lowest value indeed is actually 45 for female. Now, if you look at this place, for weight, the lowest value here is 45, and this is for female. Okay, so same goes to other ones. So, but again, I can only quickly show you this one. You can check this one again when you see the slide. So now, these are the lowest value for lowest observation. Okay, for these variables. And if you look at the top here, this and this are the highest observation observed for male and female. Okay, then this box, this section, you can see we have a box in here that is divided into two. The lower part is referred to as the Q1. This separates the lowest Q, 25% observation from the rest of the observations. Okay, then the one at the top, which is here, is referred to as Q3, okay, or quarter 3. It divides the upper 25% observation from the rest of the data. Same happens here. And if you look at this line at the middle, is the median. Okay, this median divides the lower 50% of observation from the upper 50% of observation. Okay, and these guys, this tail you are seeing, these tails you are seeing are referred to as whiskers. Okay, so all these have some kind of interpretation that you need to know, which will be seen in our subsequent classes, but these are the various components of a box plot. Now, if you need only basics of analysis, just want to analyze something very basic, then you can just use descriptive command. Okay? Then if you want flexibility to choose exactly what output you get, then you can use frequencies. But if you want to know the SQ site details or the splits, or to split the analysis by categorical variable, just like what we did for male and female just now, you can use explore. Okay, so can we show this as bell-shaped data? Yeah, for bell-shape is normality, normal. So, and how to do that? I think I've mentioned that just now. When you are when you are computing, let's say you're using histogram, there's a place where you do that. I mentioned that earlier just now. Let me quickly show you again. You see here, we have something like this, right? So how do we get this? When you are choosing your histogram, you can choose that here. You see, when you choose your histogram, this is where you check. When you check this place, you're going to have that curve. Okay, you're going to have that curve here. That shows normal curve on histogram. You're going to get that here. Okay, so now we're still going to discuss about normal distribution and how to do and how to interpret in a later class. So anyway, if you want to know the statistical details or to split the analysis by a categorical variable, then you can use explore. Okay, so today we have seen how to compute descriptive command, compute the descriptive analysis using descriptive command. You can also use frequencies and you can also use explore. Okay, so now let's quickly look at standard score. Standard score is referred to as Z-score. A Z-score is a numerical measurement that describes a value's relationship to the mean of a group of values. So Z-score is measured in terms of standard deviation from the mean. So if a Z-score is 0, it indicates that the data point scores is identical to the mean score. And if you want to compute your Z-score manually, these are the formula. This is the formula for computing a Z-score. But of course, we are looking at how this can be done on SPSS. But from the formula, Z stands for the Z-score. This X stands for observed value. This mu stands for the mean of the sample, and this sigma stands for standard deviation of the sample. Okay, so let's see how this can be computed. Assuming that I want to check my Z-score for my height and weight. Okay, so I can straight away, let's say, I can straight away go to analyze. I want to check, I want to compute my Z-score for my height and weight variables. So I go to height, I go to analyze, click on descriptive statistics, and click on descriptives. So once you open this place, by default, you're going to have all these values, all the variables you have added earlier. So you may need to remove your gender back to this place. And how do you do that? You can just drag and drop it here, or click on it and click on this button and you move it here, or you can just double click on it and it will go back to this place. Okay, so once that is done, just click on, make sure you click on this, check this place, and click OK. Okay, so once that is done, when you're going to have something like this. So you're going to have something like this. So the next thing you need to do is just to minimize this. Once you minimize this and check back your data, you'll see that your Z-score has been computed. Your Z-score has been computed. So here you have Z weight, that's Z-score for weight variable, and Z height, that's Z-score for your height variable. Okay, so now these are your Z-score, and SPSS convert each height measurement into a standardized score that tells us how many standard deviation units this score is away from the mean. So when you look at them, you observe that some are positive, some are negative. Okay, whenever you see a negative Z-score, it means that a raw score is below average. The raw score is below average. If you want to confirm that, for this particular second case, the raw score is 45. And let's see, what is the average of weight? The average of weight here is 58.5. You see? So that's to tell you, and 58.5 is greater than 45. So the raw score here for this particular case is lower than the mean. than the average of this weight. So wherever you see negative value, negative set score, that shows that the raw value is lower than the average of that particular variable. And whenever you have a positive, that shows that it is above, the raw score is above the average. If you want to check that, look at this first guy for the height, which is 0.17846. What is the raw score? The raw score is 150 for height. What is the average for this? The average is 148.2000. So which means this is higher, this is greater, and that's why it is not negative. So whenever you have a negative set score, it shows that the raw value is below average. And whenever you have a positive set score, it shows that the raw value is higher than the average. That is a quick and easy way to get a Z score in SPSS. Now, calculation SPSS. You may want to, of course, you want to describe some kind of relationship between your variables, whether you want to know whether the relationship is significant or not. Okay, one of the statistical analysis to prove this or to investigate this is known as correlation. So how do we now perform this correlation on SPSS? The correlation that we're going to be doing is called Pearson R. A Pearson correlation describes the relationship between two variables, and the value is always between -1 and +1. -1.00 and +1.00. If you have 0, if the value of your Pearson correlation is 0, it shows that there's no relationship at all between the two variables. Okay, the closer the correlation end is to either +1 or -1, the stronger relationship between the variables. In this example, we're interested in the relationship between height and weight. Okay, notice how the data have been set up. Weight and height belongs to the same person. Okay, person has a pair of scores. So the height should be paired with your weight. It is very important that each pair stays together. Okay, we have 10 pairs of scores. Remember, this missing value will be dropped. And our sample size is 10. We have 10 observations. Okay, and each pair counts as one case. This is one case, this is one case, this is one case, this is one case, and so on. So the two people without height and weight scores are not going to be included in this analysis because SPSS will simply ignore those cases with missing values. Okay, so we have understood that the values for height and weight belongs to a particular person. So now, after that, to calculate this correlation, to check whether to investigate whether there's a relationship between the two, and if the relationship is significant or not, the next thing you need to do is to click on Analyze, go to Correlate, and select by variant. Why do you choose that by variant? A Pearson R correlate two variables. So choose by variant because we're talking about two variables here. So once you select by variant, this window will happen. Then you're going to see bivariate correlation. So you need to drag and drop your height and weight into this place. Okay, once that is done, the next thing is Pearson will be selected by default. If you want to check any other one, you can also do it. But again, we're only interested in Pearson correlation. And we're going to perform two tests because we believe that we have no idea of whether there's a relationship between them or not, or whether the relationship is significant or not. So we just perform two-tier test. Then flag significant correlations. Okay, this will tell us if the correlation or whatever, if this correlation is significant, you're going to see some kind of asterisk at the end of the significant value. But if it is not, there won't be any form of asterisk. That's the essence of having this particular flag significant correlation. Then you click OK. So once you click OK, This is what you get for this particular result. So the box shown below here, this one you're seeing here is referred to as correlation matrix. Okay, it is called correlation matrix. It shows the correlation coefficient for every combination of variables. Now we have these two variables, right? We have them here, we have them at the column, we have them as a row. So now we have two rows. Okay, this one row, this another row. One for height and one for weight. We have two columns, one for height and one for weight. Where each row and column intersects, we see the correlation coefficient between the two variables. So weight intersects with weight. This is the coefficient correlation. Height intersects with weight. This is the coefficient correlation. Height also intersects with height. This is the coefficient correlation. Weight intersects with height here. This coefficient correlation. In this quadrant of matrix, if you look at this place, we see the correlation coefficient between height and itself. Height and itself, which is 1. It is 1 means that it is a perfect correlation. So anytime a variable correlates with itself, you always have perfect correlation. It will always be 1. Okay, same applies to weight. If you look at weight also, weight, correlates with weight, you are getting a perfect correlation, which is 1. Okay, so now let's look at other figures. SPSS will compare every combination of variables, including each variable and itself. We already know that every variable always correlates with itself and at a positive 1, no matter the variable. That's why you're having 1 here, 1 here. Okay, 1 here, weight correlates with variable. Weight correlates with weight. That's why you're having 1. 1 here because height correlates with height. That's why you're having 1 here. Now the intrinsic correlation here are in the off diagonals. Okay, here. The top right box is the correlation coefficient. It will always be between positive 1 and negative 1. At the moment, we're having 0.127. So below that is the significant level. You can see significant 0.210, we have 0.728. Significant level smaller than 0.05 are statistically significant. So below that is N, which is number of observations or your sample size. Here we have 10 pairs of scores. Notice that the off-diagonal correlation are the same. Here we have 0.127. Here we have 0.127. Here we have 0.1. We have 0.0. We have 0.728. Here we have 0.728. And here we have 10. We have 10. Okay. Now, because height correlates with weight exactly the same as weight correlates with height. So weight correlates with height here at this point, at this value or scores. Also, height correlates with weight at the same point. Okay, in this case, it is 0.127, which is pretty strong but not significant because the sample size of 10 is small. Okay, so in this case, P is greater than 0.05. So you are likely to get or to find a significance with higher sample size. If you have higher sample size, you're likely to get a significant value. So if this correlation was significant, we will see some asterisks next to the coefficients. So if this is actually significant, we're going to say some asterisk something here, somewhere here, because you have already chosen it while selecting the options before we come to this output. So, but at the moment, this correlation is not significant, and that's why you have the way it looks like. Now, so that is that on that. Now, that is between two variables. In case you have more than two variables, what do you do? So you can correlate more than two variables at a time. And you can even use correlation with nominal variable as long as it has, as long as it's so as long as it's only has two levels. So, and this is called a point by serial correlation. So to do this, you need to click on analyze, correlate, and bivariate again. Then inside your variables this time around, you can add the gender. Okay. Once you add the gender, include gender here, leave the other ones the way they are, and just click OK. So once you click OK, this is what you get this time around. So now you get another correlation matrix, but this time it is bigger compared to what we had earlier. This time around, you have three rows, and of course, three columns as well. But what you have to notice is that wherever the variable correlates with itself, there's always perfect correlation. That's why you have one. One here, gender correlates with gender, height correlates with height, weight correlates with weight. Then you have one. Okay? The correlation between height and weight, between height and weight, are exactly the same as before. So you have 0.127. But we also have correlation with gender. Okay? So which are, if you look at height with gender, you have minus 0.293. Okay? And for weight and gender, you have minus 0.167. Because the correlation are negative, as one variable goes up, the other goes down. Okay, remember that we coded males as 1, okay, and female as 2. So the 1 is smaller. So in this negative correlation, the smaller number are associated with a larger value. The smaller number, which is 1, is associated with the larger value. So basically, the males were taller and weighed more than the females. This is the interpretation of this. So P, that's P value, open bracket, 0.645, we're having here, is greater than 0.05. Shows there is no significant relationship between weight and gender. So this is how to perform correlation analysis. And how do we now build scatter plots? The first scatter plot is very important, and again, we're going to do more about this later. But a scatter plot, also known as scatter chart or scatter graph, some of you call it scatter diagram, uses dots to represent values for two different numeric variables. So the position of each dot on the horizontal and vertical axis, got something here, indicate values for an individual data point. So scatter points are used to observe relationship between variables. Okay. Next is how to make a picture of the correlation matrix that we just created in my previous slide. The picture is called a scatter plot, and it is created using a tool called Chart Builder. How do we get this chart builder? You click on graphs. This time around, you are not using analyze. Graph is next to analyze. Graph tab is next to analyze. So you click on graphs. So when you click on graphs, you select chart builder. So after you select a chart builder, this window will appear. Okay. So here we need scatter diagram. If you want a line chart, if you want a bar chart, you can also create it from here. But this is what we are interested in. We are interested in scatter diagram. So you click on scatter/dots. So once you click on that, we have various types of scatter plots or chart that you can choose from, depending on what you want. If you hover your mouse on each and every one of them, the name of each of them will be displayed. But what we are interested in, we need a very simple one. So just click on this particular first one and drag it here. Click and drag into this environment. And once that is done, you're going to have something like this. Okay, so you click and drag this into this place. And once that is done, you will see something else. So the first one we are creating, we drag is simple scatter. Simple scatter. Okay, so next is to click and drag into the canvas as shown. After you've done, then you need to add your variables order to the corresponding Y and X axis. You have filter here. If you want to filter, if you want to filter by maybe some kind of variable, like gender that we did just now. But this time around, we're not interested about that. We're only interested about the height and weight. So you drag the height to the X axis, which is here. You just drag the height here and put it here. And you drag the weight and you place it here. Once that is done, this is what you get. Okay, your plot has already been created anyway. So the next thing you do is, if you want to add some name here, some caption, something like this, so you just click on this title stroke footnote, then you can enter whatever name that you want. But for now, I just leave it the way it is. So you just click on OK. So once you click on OK, this is what you get. Okay, so this is what you get, which is actually your scatter plot. Now you have to show the scatter plot of all 10 of the PS course that we examined. Okay, now there are much more that could be done with correlation. For example, we could format the scatter plot in APA star. We could do other types of correlation as per research requirements. We could even use some variables to predict other variables using a technique called regression. We will learn more about scatter plot, simple regression, and multiple regression in our next class. Okay, correlation are about relationship between variables, but we might also be interested in differences between variables. What if there's no relationship? What are the differences between this variable? So in our next class, we'll learn how this can be done using t-test, and also how this can also be interpreted. Okay, so on that note, we have come to the end of today's section. If you have any questions, please let me have them. So I have shared the attendance link on the chat group. So please fill it up and submit. So if you have any question, please let's have it. Okay, so in the absence of none, thank you, stay safe, and see you again next week. Bye. Hello, can you hear me? Okay, thank you.